Good evening, guys. Good evening, guys. If you can hear me as usual, please comment. I can hear you. Yeah, so I want to see the comment section rolling. I can hear you. If you can hear me, see, I can hear you. So, ladies and gentlemen, if you are just new to this channel, please like, subscribe, like you can see displaying on your screen. That's the only price you pay for being a member of Jaex Academy, this online platform. So right now I'm trying to invite others. So I just posted the link to my nursing group. If you are a JAMB, please comment I'm a JAMBite. Why comment why nothing comment nothing. Um, Alright, I think we are set right now to dive into the class. So I say this once again. If you are new to this channel, subscribe. That's the only price you pay for being a member of Jaex Academy and a bona fide member of this online class. Marvelous Chief Norm, I see you. Jao, I see you. Edro Gideon, I see you. Prosper, I see you. Donatus, I see you. Jessica Koro, I see you. I see you all. Alright. Now, if you are new to this channel, subscribe as we dive into the course. Nursing student, I see you. Good, I see you. Good, you don't miss any of my online class. I love that. So let's dive into the course properly. Ah, Victor, I see you. So, ladies and gentlemen, this is an introductory class to organic chemistry. Now, some of you see chemistry as a demon or organic chemistry as a demon. So, I want to encourage you tonight. Okay, Jessica, I see you. I see all my nursing students. Shout out to you guys. Yeah, Jessica Okoro said I'm new. Yes, yeah, you're new here. Please subscribe to this channel. Yvonne, I see you. I see you. All right. So, like I was saying that organic chemistry is the most easiest thing in chemistry. It's the most easiest branch in chemistry. So tonight, everything we are going to be doing tonight is just an introduction. I want to encourage you all to follow up with this introduction because when we start introducing part two, you'll be seeing a lot of nomenclature. Okay, Vincent Brume, my speaker is in the highest volume. I'll try to speak louder. So I believe you all can hear me very well. I'll try to speak louder. All right. So Gloria said she cannot hear me. Okurume Gloria. Please, I have to ensure that you all can hear me before I continue with the class. You can hear me very well. So please, if you can hear me, say I can hear you. Let me continue with the class. Yeah, majority said they can hear me. Okay, for those of you that cannot hear me, please get your earphone or your headset on. Okay, for those of you that cannot hear me, please get your earphone or your headset on. So let's continue with the class. Like I was saying, organic chemistry is very easy. I don't know why they like scaring students with it. So tonight, what we'll achieve tonight is an introduction to organic chemistry. Now, after tonight's class, our next class, our next class will be looking at more complex stuff like naming of organic compounds, organic chemistry reactions. They are easy, right? I'm with you guys. Why are people saying they cannot hear me? Why are people saying they cannot hear me? Otuki, I see you. So please connect. Those of you that say you cannot hear me, connect to an earpiece. Or now, quickly, what is organic chemistry? Now, organic chemistry is the study of hydrocarbon. So I repeat, organic chemistry is the study of hydrocarbon. Now, what is hydrocarbon? Hydrocarbon is the combination of hydrogen and carbon only. So I repeat, organic chemistry is the study of hydrocarbon. What is hydrocarbon? Hydrocarbon is the combination of hydrogen and carbon only. Now, moving forward, organic chemistry is the study of hydrocarbons and their derivatives. It involves the study of covalent bonded compounds, and the major element is carbon. So, what this means is that in organic chemistry, the major element is carbon. Now, carbon have three reasons, or there are three reasons why carbon is the main element or the major element. So I repeat, in organic chemistry, the major element is carbon. And there are three reasons why carbon is a major element or the main element. Are you guys still following? Remember, we have to learn from a simple level first before we start climbing up. So let me be sure that you people are following me from this simple level. Are you guys still following? Now, if you understood what I just said, if you understood what I just said, please answer this question. If you understood what I just said, answer this question. If you understood what I just said, if you understood what I just said, please answer this question. The compounds made up of only carbon and hydrogen are called dash A. Carbon compounds, B. Hydrocarbons, C. Atoms, D. Carbon hydrolysis. If you understood what I just said, comment your answer. Only carbon and hydrogen are called dash A. Carbon compound, B. Hydrocarbon, C. Atom, D. Carbon hydrolysis. If you understood what I just said, comment your answer. Alright, indeed, B is the answer. You can always come back to this video, please. Now, let's go back to the definition of hydrocarbon. Sorry, organic chemistry. So we said that organic chemistry is the study of hydrocarbon, and hydrocarbon is made up of um, hydrogen and carbon, right? So we said that in organic chemistry, carbon is the main or the major element. Why is carbon the main or major element? It's because of three reasons. Now, let's look at the reasons. Number one, carbon has the ability to catenate. Carbon has the ability to catenate. So if you are new here, like and subscribe to this channel. Let's continue. Carbon has the ability to catenate. What does it mean? Number one, it has the ability to form either long chain, branch chain, either long chain, branch chain, or closed chain. Now watch your screen. Watch your screen, guys. Carbon has the ability to catenate. What is catenation? It means that carbon can either form long chain. Are you seeing? When it is straight, when the chain is straight, it is known as a long chain. Now moving forward, I can just clean this guy. Let me clean this guy. Now moving forward, I can say carbon has the ability to perform branch chain. Now look at this very well. Look at this guy very well. Now what it means is we have a chain like this and it was branched. You see, it was branched. So for this reason, it is still part of concatenation because it branched. I believe you all can still see my screen. You can see what I'm doing. So let me clean this guy. So the first one, you see the green line. The green line is a straight. The second line, which is yellow, is kind of branch. Then the third line, okay, I've not drawn the third line. The third one is a ring shape. So carbon carbon can has the ability to carbon has the ability to catenate, right? When we say catenate, we are talking about it either forms a straight chain, a branch chain, and closed chain. Are we there? So that is one reason. So if you understood what I just said, comment catenate. If you understood this thing I just said, comment catenate. Comment catenate. Comment catenate. If you understood what I just said, comment catenate. If you don't understand, say I don't understand. We are my nursing students. If you don't understand, say I don't understand. You are my nursing student. All right, so let me explain again what I mean by this. So I said in organic chemistry, carbon is the major element. In organic chemistry, carbon is the major element. Now, why is it major element? It's because of three reasons. And these three reasons is what I'll be talking about. Now, number one reason, carbon has the ability to catenate. Now, why is it major element? Carbon has the ability to catenate. Now, what is the meaning of catenation? The meaning of catenation is this. Number one, carbon has the ability to form a straight chain. So what we say straight chain, we are talking about straight line. Number two, carbon has the ability to form branch chain. Right? What is branch chain? Let's say we have something like this. This is the branch chain. Then the last one is we are still talking about concatenation. The last one is closed chain. This closed chain is like a ring chain. So we have something like we have. Let me clean this. Then the last one is we are still talking about concatenation. The last one. So do you guys understand? When we say catenation, it means it can form straight chain, branch chain, or closed chain. Closed chain is like a ring structure. Closed chain is like a ring structure. You guys can see my screen. When we say catenation, it means it can form straight chain, branch chain, or closed chain. Closed chain is like a. So do you guys understand now? So do you guys understand now? Okay, so let's proceed. Now, we are looking at three reasons why carbon is the major element in organic chemistry. Number one, we said it has the ability to catenate. Okay, so let's proceed. Number two, we are looking at carbon can combine easily with hydrogen, nitrogen, and halogens. I repeat. Number two reasons is that it can combine easily with hydrogen, nitrogen, and halogens. Nitrogen and halogens. Then the last one is that it has the ability to form single, double, and triple bond. The last one is that it has the ability to form single, double, and triple bond. The last one has the ability to form single, double, and triple bond. Now, when we say single, double, and triple bond, listen, ladies and gentlemen, if we have this, this is a single bond. Now, when we say single, double, and triple bond, if we have something like this, up, down, this is the double bond. Then if you have something like this, let me use different color. This is a triple bond. I repeat. Let me clean the double bond. Then if you have something like this, I repeat, if you have this is a single bond. If you have this is a double bond. If you have this, this is a triple bond. So I'm saying that this is a single bond, S for single, D for double, then T for triple bond. Are you guys still following? If you are still following, comment I'm following. If you are still following, please comment I am following. Let me know those are still with me. I'm following. I can't hear you. Can you keep the comment rolling in? Say I'm following. Following, please comment I'm following. I want to see the comment keep rolling in. Where is Utsuki? Where is Mr. Bleeze? Where are you all? All right. So I said this is a single bond. I said this is a single bond, this is a double bond, and this is a triple bond. All right. So let's move forward. Now, remember this is an introduction to organic chemistry. So we might not be looking at anything complex tonight, because if we start with complex things, you guys might be lost. So I want to carry you off from the scratch level. So please try as much as possible to follow me carefully. Ladies and gentlemen, in chemistry, let's look at basic terminologies. Ladies and gentlemen, if you are new to this channel, the only thing you have to do to be a member and bona fide student of our ninth class is when you subscribe. So if you are yet to subscribe to the channel, do that right now. Now the next thing we'll look at is the basic terminologies. In organic chemistry, we'll look at some terminologies. If you don't know these terminologies, you will flop. If you don't know these terminologies, you'll be lost. Organic chemistry will look at. So I repeat, if you don't know the right terminology, you will flop. and you'll be lost. So the first terminology we'll be looking at is homologous series. So I repeat, if you don't know the right terminology, no. The terminology we'll be looking at is now homologous series is a family of organic compounds, all right, that follows a regular structural pattern in which successive members they differs by CH2. Now, what this means is homologous series is a family of organic compounds, right, that follows a regular structural pattern in which successive members differs by CH2. Now, what this means is let's look at an example. Okay, let's look at an example. Now, ladies and gentlemen, I have C. Now, what this means is let's look at an example. Okay, let's look at an example. Now, ladies and gentlemen, I have now this is a methane gas. I believe you all can see, and this is methane, and I have CH. Now, this is a methane gas. I believe you all can see, and I have all right. Yeah, Jessica Okura, I know you are new, so just subscribe and follow up with the class, please. All right. Yeah, Jessica Okura, I know you are new, so just subscribe and follow up with the class, please. Now, okay, all right. So Faith said I'm following. Can you see my screen, guys? Now, are you seeing my screen, guys? Are you seeing the parts I circled red and the part I circled green? Now, the part I circled red is a methane. Now, are you seeing my screen, guys? The part I circled green is ethane. Good, good. I'm glad you can see it. Now, what is homologous theory saying? It said that each successive members differ from CH2. Each successive members differs by CH2. Now, let's look at this. This is methane and this is ethane. So let's count how many hydrogen atoms we have here. So we have one hydrogen, right? We have two hydrogen. We have three hydrogen. We have four hydrogen, right? So let's now move to the other side. This side, let's count here. The green side now. We have one hydrogen. We have two hydrogen, right? So let's now move to the other side. This side, let's count here. The green side now. we have one hydrogen, we have two hydrogen, all right. So my mic is on and it's turned to the loudest volume from my end. So please, if you cannot hear me, can you guys still hear me? All right. So my mic is on. I'm so sorry if it's going up and down. All right. So I was saying that this is compound one, this is compound one, and this is compound two. I'm so sorry if it's going up and down. All right. So I was saying that this is compound one, compound one, and this is compound two. So this is compound one and compound two. Now, if you look at compound one, you can see we have four hydrogen here, right? And one C. Can you guys see this C? Four hydrogen and one C. Now, if we look at compound two, you see we have two hydrogen, so this is compound one and compound two. Two hydrogen. If you look at compound one, four hydrogen here, right? And one. Can you guys see? And how many hydrogen? The red one are one, two. Compound two, you see we have one, two, three, four, five, six. Right? So what is the difference between compound one and compound two? Is that they differ by CH2. Do you guys understood what I just said? If you understood, say yes, we get you. So what is the difference between compound one and compound two? Is that they differ by CH2. Do you guys understood what I just said? If you understood, say yes, we get you. I'm waiting. All right, so let's proceed. All right, let's proceed. Now, everything I just said now, when we talk about homologous series, we are talking about the alkane group. When we talk about homologous series, we are talking about alkane group. We are talking about the alkene group, and we are talking about the alkyne group. We are talking about the alkane group. So now I want you to I want to draw your attention to the names. Now, when we start naming from our next class, please take note of what ends the for alkenes, what ends it is ins. For alkynes, what ends it is ines. And they have a structural formula. So structural formula for alkenes is CN H2N plus 2. Structural formula for alkenes is CN H2N. For alkynes, the structural formula is CN H2N minus 2. Please take note. H2N. For structural formula is H2N minus 2. Please take note. Are we still together? Did you guys just understood what I said? Did you guys understood what I just said? Please comment before I move forward, because very soon you start seeing JAMB question. PTS students, you start seeing questions. You guys just understood what I just said. Please comment before I move forward, because very soon you start seeing JAMB question. PTS students, you start seeing questions. This choice, is it the Dream Masters on Jaex Night Group? Okay, I repeat. We said homologous series are members of organic chemistry that they differ by CH2. Now, this CH2 is the difference in homologous series. So we now look at this. We look at compound 1 and compound 2. What is the difference between compound 1 and compound 2? Now, if you look at compound 1 has just one C and have 4 hydrogens surrounding it, right? 4 hydrogens surrounding it. Then compound 2 has 2 carbon and 6 hydrogen atoms surrounding it. Now, if we subtract CH4 from C to H6, we'll be left with CH2. Now, the CH2 is what we now say that it is homologous series. Now, we now look at some types of homologous series, examples of homologous series. We said alkanes are members of the homologous series. We said alkenes are members of homologous series. Alkynes are members of homologous series. Now, for alkenes, we have Cn H2n plus 2. That is their molecular formula. Forget about it first. But when we'll be solving later, when we'll be naming compounds later, we'll apply it. I will call your attention to it. What we are doing tonight is just a foundation class of organic chemistry. Alkenes has structural formula or molecular formula of CnH2n. Alkynes has CnH2n minus 2. Do you understand now? All right, so let's now look at alkenes as a member of the homologous series. Look at the table, guys. Please look at this table. Let's look at alkenes. We are looking at alkenes right now. Alkenes. All right, so let's now look at alkenes. Look at the table, guys. Please look at this table. We are looking at alkenes right now. Alkenes. All right. So look at this table. The first member of alkenes is methane. I repeat, the first member of alkane is methane. And methane has a structural formula of CH4. If you expand it, we have, please look at the board though, sorry, look at the screen. If we expand it, we have this structural formula of H4. We have, please look at the board though, sorry, look at the screen. Can you see what I just did? If you are still following, please comment following. Here's O2K. If you are still following, comment following. See what I just did? If you are still following, please comment following. Here's O2K. Comment following. Can you see clearly now? Miracle and um Shuku. Please, can you see clearly now? Can you see clearly now? Miracle. All right. I'm glad. So this is a jump question for you guys. Jump will ask you what is the shape of methane. This is the shape. Look at the shape. Watch your screen, guys. All right. Right. So this is a jump question for you guys. The shape of methane is tetrahedral. 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 Please, can you see my screen now? Yeah. So I said the shape of methane is tetrahedral. This is how it's spelled. Can you see? Can you see my screen now? Yeah. So I said the shape of methane tetrahedral. This is how it's spelled. Please, are you guys still following? Please, let's ensure we are together so that we can move forward. We have a lot to cover tonight. Please, are you guys still following? Delete. Okay. Please, let's ensure we are together so that we can move forward. All right, let's go now. So, ethane is another member, is the second member of um alkanes. So you see that this was what I was trying to draw the other time. You see that we have 2C H, right? What is the difference between methane and ethane? The difference is CH2. right, is CH2. So moving forward, the third member is propane. The third member is propane. So let me give you guys the food table. This is the food table. This is the food table. This is the food table, guys. Now, in those days, how I used to cram the table is this. Look at my screen, guys. M stand for mama, E stand for ejiro, P stand for block, B stand for big, P stand for plantain, H stand for Hillary, H again stands for Ansin, O stand for Ochuko, N stand for no, then D stand for day. So if I wrap it up together, I will say Mama Ejiro plug big plantain, Hillary Ansin Ochuko no day house. So what is Mama, which is M, is methane. What is Ejiro? E, ethane. What is P? Plug propane. What is B? Big butane. What is P? Plantain. Pentane. What is Hillary? H, enzine. What is Ansin? H, Ansin. What is O? Ochuko. Octane. What is N? No, nonane. What is D? De, decane. Has. Has no get anything. So, Mama Ejiro plug big plantain. Hillary or Ansin Ochuko no D has. Did you guys get these acronyms? Ladies and gentlemen, this is just a foundation to organic chemistry. I want to ensure that you guys are flowing with me in this class, understanding the basics, because in our next class, you'll be seeing some complicated structure. Ladies and gentlemen, this is just a foundation to organic chemistry. I want to ensure that you guys. So, if you are just new here, like, subscribe to this channel so that you'll be getting notification of our next classes. Now, moving forward, to ensure that you guys understood all the grammar I just spoke, answer this question. Answer this question for me, guys. This is an exam question. Which of the following could not be arcane? They say all of these options are arcane, but except one. Except one. Let me give you guys a expo. Oh yeah, oh. An example question. Which of the following could not say all of these options are arcane? Oh yeah, oh yeah, oh yeah. I'm giving you guys a expo. Which of the following could not be arcane? If you understood everything I just said, oh yeah. I'm waiting, oh. Oh yeah, oh yeah, oh yeah. I'm giving you guys a expo. Which of the following could not be arcane? Understood everything I just said. Waiting, oh. Jesus. Jesus. Guys, your answer is not correct. Okay, let's do it together. Let's do it together. Yeah, God bless you. The answer is C. Which of the following is not a member of alkane? So the first option, this is the first option. The first option is C. Now let's look if C for H10. Look at C for H10 is a member. Now let's go again. The second option is C5 H12. Let's look at the table again. C5 H12 is in the table. The next one is C7 H14. Let's look at the table. C7, we have C7 H15 here. And over here we have 14. So automatically this one is hard. Next one is C7H14. Let's look at it. Then the last one is C8H18. C8H18 and over here we have 14 is on the table. So this is correct. So ladies and gentlemen, the only one that is not correct is C. A lot of you are complaining that the screen is not clear. I guess this is coming from YouTube. Oh. Ladies and gentlemen, the only one that is not correct is C. Okay, is the word bold enough now? Um, YouTube is blurring the videos. Is the word bold enough now? Um, blurring all right, all right. Thank you, ladies and gentlemen. So let's continue. Can we continue? So, ladies and gentlemen, we are still looking at terminologies of organic chemistry. Terminologies of organic chemistry. All right. So, number three terminology we've just talked about. Remember, we just talked about terminologies of organic chemistry. Yeah. So we just talk about homologous theories. So let's look at number three, functional group. So when we talk about functional group, we are talking about single bond. You can see over here we have single bond. Yeah, so we just talk about homologous theory. So over here we have single bond. Over here we have double bond. Now the reason why we are doing functional group is because when you be naming, please don't ask me how did you get double here, how did you get single here, single bond here, how did you get triple bond. So please follow the introduction. Over here we have double bond. Now the reason why we are doing functional group is because when you be naming, please don't ask me how did you get double here, how did you get single here, single bond here, how did you get yeah. I must have missed it to write number three, but I guess number three is number two as well. All right, so sorry. Now, single bond is this 1, double bond is 2, triple bond is 3. So this 1, 2, 3 respectively is known as functional group. Is known as functional group. I dey talk o. Now, ladies and gentlemen, the last thing I want you all to know tonight, before I start giving you a lot of JAMB question, is this. Now look at this table. Please, I beg you in the name of God. Screenshot this table now. Screenshot it now. The last thing I want you all to know tonight, before I start giving you JAMB question. Please screenshot this table. Screenshot this table. Please, I beg you in the name of God. Screenshot this table now. Screenshot it now. Are you ready? If you have done that, let me know. If you have done that, please comment on the comment section. Just give me the keyword screenshots. If you have done that, let me know. The comment section. Just give me the keyword screenshot. Comment screenshots. Alright, so let's go now. Open your ears, oh, I beg you in the name of God. Now, this first one is alkanes. This is the general formula for alkanes. You can see the general formula for alkanes. Introduction, no, because in our next class, I will not be teaching like this, though. This is the general formula for alkanes. Now, this first one is alkane. And they have single bonds. They have single bonds. Now, this is the general formula for alkanes. Alkene has double bonds. The alkenes. Now, this is the general formula for alkenes. These are alkenes, and alkenes have triple alkynes. Sorry, alkynes. Sorry, alkynes have triple bond. Now, are you seeing this third one? Alkynes. Listen, alkynes. Let me echo it first. Now, are you seeing this third one? Alkynes decolorizes ammonica silver. Note, write it down. Sorry, alkynes decolorizes ammonica silver. Ammonica silver. Note, write it down. Sorry, alkynes. Alkynes decolorizes ammonica silver. Write it down. See, this is alkynes decolorizes ammonica silver. Then alkenes. This is alkenes. This is alkenes. Alkenes and alkyne. Alkenes and alkynes decolorizes bromine water. I repeat, alkenes and alkynes decolorizes bromine water. Only alkynes decolorizes ammonica silver. Una dey understand am so? Please, if you don't understand it, let me know. Let me know. Okay. Okay, two persons says they don't understand. Oh yeah, look at, just watch your screen. Now look at your screen. Are you seeing I circle alkynes, only alkynes? I circle only alkynes. This is theory question, so alkynes decolorizes ammonica silver. I spent ammonica silver. Why does it decolorizes ammonica silver? Because it contains a double bond. Sorry, a triple bond. Why does it colorize ammonica silver? Because it contains double bond. Sorry, a triple bond. Alkynes decolorizes. Note it. I'm not solving anything. It is a note. Alkynes decolorizes ammonica silver. That's it. Dey bleach ammonica silver. Ammonica silver colorize na dye. If you add alkynes to the dye, it's going to bleach it. Una understand am? Una understand wetin I talk? Na dye. If you add alkynes to the dye, it's going to bleach it. Una understand am? Una understand wetin I talk? Now, moving forward, alkenes, alkenes, alkenes. Let me circle alkenes now. Alkenes, alkenes and alkynes, two criminals. Alkenes and alkynes na two criminal. Two of them dey decolorize bromine water. Two of them dey decolorize bromine water. For example now, if bromine water na blue, you go add either alkenes or alkynes together or separately in bromine water, it's going to remove the color. Una hear wetin I talk so? Note am down o. One calmly question you. You people will see question. Color. Now, please, if you understood this, comment yes, sir. If you understood this, please comment yes, sir. All right. Yeah, I can see that. Omo Rabi dey here o. Yeah, I can see that. Omo Rabi dey here o. Yeah, I'm back, guys. Sorry for the break. So let's just wrap up. Let's wrap up. You can still hear me. I believe you guys can still hear me. Glory, Gloria, I'm not solving any question. I'm just saying that Akin's accounts decolorizes decolorizes bromine water. Bromine water is blue. When you add either Akins or Akines to it, it's going to decolorize it. Gloria, I'm not solving any question. Do you know what? We'll take question. I will draw your attention to it. Now, we've talked about Akins and accounts. Now, hope you guys are aware that Akanos is still the same thing as alcohol. I repeat, hope you guys are aware that Akanos is the same thing with alcohol. Akanos is still the same thing as alcohol. I repeat. Now, the general formula for Akanos is this: alcohol. Then the next thing we now look at is Akanas. Akanas are derived from alcohol. Is this. Then, ladies and gentlemen, the last thing we'll look at before taking JAMB questions, PTS question, is this: Esters. Esters, in fact, esters is what they used to do perfume. Esters is what they used to do perfume because they have a good scent. Also, fruits when they scent, sometimes they are esters, and this is their general formula. So anything that has sweet and pleasant smell are usually esters. Now, to ensure that everything I've been saying, you understood it, here's a question for you guys. Question one. Oh, yeah. Faith, yeah, they are Akano, but relax. This is an introduction class. Now, to ensure that everything I've been saying, you understood it, here's a question for you guys. Question one. Oh, yeah. Faith, yeah, they are Akano, but relax. This is an introduction class. Oh, yeah, oh, yeah, oh. Okay, let me give you guys a expo. See the table. Akanas. Expo. Akanas. Expo, look at Akanas. So you should look at Akanas. Then go back to the question. So what is the answer? You people are getting BD. Okay, let's go back to the table. CHO. Alright, so the answer is definitely B. So what is the answer? People are getting B. Okay, let's go back to the table. Okay, the next question for you guys. CHO. Alright, so the answer is definitely B. The next question for you: which of the following functional group with decolorizes ammonica silver? Which of the following functional group with decolorizes ammonica silver? Which of the following functional group with decolorizes ammonica silver nitrate? Whip and come. See, una don dey answer organic questions, so organic chemistry like this, so no forget say this one na just the foundation. The real class is coming very soon. Functional group with decolorizes ammonica silver nitrate. Whip and come. All right, guys. So the answer is indeed C. Next question. So the answer is indeed C. Next question. Hydrocarbon, hydrocarbons. Oh, I did not say this. Okay, I did not say this. I did not say this. I did not say this. Okay, so the answer for this one is C. I did not say this. Hydrocarbons. Oh, I did not say this. Okay, I did not say it. I did not say it. Next question. Okay, so the answer for this one is C. The next question. I did not say it. The next question. Which organic compound is responsible for characteristics of aroma of fruit? A. Alkane. B. Alkyne. C. Ester. D. Amine. Yeah, uh, PTS students, the last questions I said, I gave you guys PTS question, but this one is specifically for JAMB. Ladies and gentlemen, I said Easter is responsible for sweet smell, sweet fragrance, sweet fragrance, sweet smell, lovely smell. Anything that is sweet is Easter. So the answer is indeed C. Is responsible for sweet smell, sweet fragrance, sweet fragrance, lovely smell. Anything that is Easter. So the answer is indeed C. Now, ladies and gentlemen, before we go to bed tonight, are you tired? Let me know. Are you tired? Are you tired? Comment, comment. If you are tired, let me know. If you are tired, let me know. Now, ladies and gentlemen, Are you tired? Remember that JAMB is just around the corner. Okay, go and sleep. Okay, so since you guys are not tired, I will quickly wrap it up with this. Another terminology we should look at is saturated and unsaturated hydrocarbon. So, what are saturated hydrocarbon? When we say something is saturated, it means say e don dey belleful. Una understand? E don belleful, e no go fit accept again. Now look at this guy. Look at methane. If you look at methane very well, you see that every corner of methane is filled with hydrogen. That is to say that methane gas cannot accept any again. I repeat to when we say saturated, we are saying that uh, the hydrocarbons are joined with single bonds and they can no longer accept any more atoms. Now, when we say unsaturated hydrocarbon, it means that they are either double or triple bonds and they still have space. Now, look at this guy. We have space here, space here, space here, space here. Please, do you understand saturated and unsaturated hydrocarbons? If you don't understand, say no, I don't understand. If you don't understand, say no, I don't understand. Do you understand saturated and unsaturated hydrocarbons? If you understand, say yes, I understand. Say no, I don't understand. If you don't understand, say no, I don't understand. All right, so let me repeat what I said. Oh yeah, Gota, thank you, Otene, Otuke, yeah, Miracle Berry, yeah. Okay, so I will explain again. Saturated hydrocarbon consists of only single bond. They are joined with just single bond, and it means that they are feed, they are satisfied, they don't belleful in a layman's language. Now, look at this compound. Let me circle it for you guys. Now, if you look at this compound, we have ethane and ethane. Now, ethane or methane, let's use ethane. Let's use methane. As methane dey here like this, though, methane don't full. You understand? This first corner, this up don't full. The side don't full. The right don't full. The bottom don't full. So you no go fit shook hydrogen for any place here again. Unless you want to say yeah and yeah. If you say yeah and yeah, you are already doing chemistry blunder. So respect the four cardinal points. It is feed. So what are we now saying? We are saying that for saturated hydrocarbon, they are they are joined together by single bond and they are feed. Now for unsaturated hydrocarbon, let me circle it. For unsaturated hydrocarbons, we are saying that they are joined by either double bond or triple bond. Now, they are joined together by either double bond or single bond, and they are not feed. they no fit. Space still dey. They never chop belle full. Space still dey. So I can decide to come and say, yeah, I can add hydrogen here. I can add hydrogen here. Add for bottom, add for here. Una understand? They never chop belle full. Space still dey. So I can decide to come and say, yeah, I can add hydrogen here. I can add hydrogen here. Add for bottom, add for here. Una understand? Gradually, we are coming to the end of this class. Ladies and gentlemen, if you are new, subscribe to this channel now. Click on the subscribe button. So we now talk about hybridization quickly. See, make we not confuse ourselves. Hybridization means SP, SP cube, and SP cube. SP, SP2, and SP3. Una dey see am for screen, abi? If una dey see am for screen, comment I dey see am. Hybridization means SP, SP2, and SP3. All right, I'm glad. So this is where it's going to get technical. Make una see am o. Now for alkanes has sp3 hybridization. I repeat, all alkanes have sp3 hybridization, and the bond angle for alkanes is usually 109.5. Write it down. All alkanes. Remember that alkanes are single bonded compounds. Alkanes are single bonded compounds. Alkanes are simple bonded what compounds. Their hybridization is sp3. Their hybridization is sp3. And the bond angle is 109.5. Their bond angle is 109.5. Talking about alkenes are double bonded compounds, and their hybridization is sp2. Their hybridization is sp2. Bond angle is 120 degree. Bond angle is 120 degree. For alkynes are triple bonded compounds. They are triple bonded compounds. The hybridization is sp, and their bond angle is 180 degree. Write it down or screenshot it now. Compound. They are triple bonded compound. The hybridization is sp, and their bond angle is 180. Write it down or screenshot it now. Do you guys understood this English I just took? All the English when I speak now, and I understand that. Do you guys understood this English I just took? All the English when I understand that. I repeat one last time. All alkanes are single bonded compounds. they have sp3 hybridization, and their bond angle is 109.5 degrees. For all alkenes, the hybridization is sp2, and the hybridization is sp2, and their bond angle is 120 degree. Note it, note it. You are not solving anything here. Note it. Just screenshot it and write it in your note. All alkynes have hybridization of sp, and their bond angle is 180 degree. So please, Faith Idigu, please, I want you to think. I want to ask you guys one simple question now. Are you guys ready? Are you ready to answer this question? Are you ready? Oh yeah, answer this for me. I want to ask you guys one simple question now. Are you guys ready? Are you ready to answer this question? Jessica Okoro, answer this for me. Oh yeah, this is the question. Now we have more than one hybridization here. This is a single bond, this is a single bond, and this is a triple bond. And the question says, this is a JAMB question. This is a PTS question. And the question says, the hybridization in the compound is dash. Please answer. You people are saying a are you people sure? This is a PTS question. And the question says, the hybridization in the compound is dash. Please answer. You people are saying are you people sure? Ladies and gentlemen, the answer is A. A have it. So let me repeat. Let me repeat something. See, we say as far as it gets triple bond, the hybridization is sp. As far as it gets double bond, hybridization is sp2. As far as you get one bond, hybridization is sp3. Let's go back to the question now. As far as you get triple bond, the hybridization. So in this compound, we have double bond. When I see the double bond, we get double bond, we get double bond, and we get triple bond. Triple bond. Now this one, double bond na sp. So in this compound, we have sp3. When I see the double bond, we get double bond. For triple bond na sp. Now this one, double bond sp. And I see am. So ladies and gentlemen, this is everything about introduction of organic chemistry. Ladies and gentlemen, this is everything about the introduction of organic chemistry. Now, in our next class, we're going to be looking at part 2. Now, in part 2, we'll look at the naming of organic chemistry. part 2, we'll look at naming of organic chemistry. Now, in part 2, and we'll look at reactions of organic chemistry. So, ladies and gentlemen, with this, we've come to tonight's class. With this, we've come to tonight's class. So please, we have few minutes to answer your question. If you have a question, please ask your question right now. If you have not subscribed to Jaex, do that tonight. Subscribe now. Please ask your question. Ask your question. We are done with everything on introduction to organic chemistry. The next thing we'll be looking at is naming of organic compounds. We are done with everything on introduction to organic chemistry. The next thing we'll be looking at naming of organic compounds. Yes, okay, mini. Yes, you can get access to other subjects. You can get access to other subjects. As a matter of fact, we have a ninth group where we teach physics, chemistry, mathematics, English, biology. But we decided to be giving our chemistry classes for free, and that's why we are doing it on YouTube. So yeah. So if you want to get access to all our courses, you enjoy what we do, you want to further, please send us a DM so that you can join our ninth class. Our ninth class group is separate from this YouTube channel. Ladies and gentlemen, thank you so much and good night. Please send us a DM so that you can join our ninth class. Our ninth class group is separate from this YouTube channel. Ladies and gentlemen, thank you so much and good night. Faith Idigu, all these questions that you people are asking are a kind of complex class that we're going to have later in the future, right? So what we focus on today is just an introduction class. So I promise you, we are going to tackle every of your question in our next class. Marvel, Marvel, you can come to my DM for that. Send me a direct message. All right, good night, guys. So I promise you, we are going to uh, tackle every of your question in our next class. Marvel, Marvel, you can come to my DM for that. Send me a direct message. All right, good night, guys.